proceed.
Okay. Good morning. Today I would like to present second of my presentations. I would like to focus on the climatic reconstructions from the Serteya, Great Serteya Paleo Lake, localized in the western Dvina Lakeland, and reaction of aquatic biota for the climatic and habitat changes from the sediment reconstructed from the sediment of this lake. Serteya region is localized at Smolensk upland. This is close to the Belarusian border. Actually, Serteya River Valley was investigated since late 90s of the 20th century by the State Hermitage Museum. According to the archaeological issues, this appeared very interesting region for archaeologists, and the Serteya River Valley was extensively investigated according to the Neolithic findings and also Mesolithic relics and so on. However, until now, there are only weak evidence for the environmental background of this archaeological facts, and only last year there was published paper by Tarasov and co-authors in Quaternary International, where they present a high-resolution reconstruction of the paleobotanical evidence from the Great Serteya Paleo Lake. In fact, the Great Serteya Paleo Lake is one of the most important localities for archaeological investigation in the valley, and that's why we decided to collect two cores from the site, actually from the site ST2, wait for a moment, oh, here, and ST2 and STM25. At this locality, at these sites, there are the most important archaeological excavations in the Serteya Valley that concern pile dwelling localized at the Neolithic pile dwelling localized at the lake littoral, and also excavated in the last years skeletons from the lake shore. As I told, it is quite an interesting site for archaeologists, mostly because there are numerous sites where there were excavated very early Neolithic settlement in the northern Europe. There were collected, for example, pottery remains from the Rudnaya Lake depression, and the earliest Neolithic sites in the valley comes from the 8,000 years before present. Of course, for a long time up to the late Neolithic, the communities living in the Serteya Valley revealed hunter-gatherer economy. However, they developed advanced culture and advanced, including, as I told, pile dwelling and many constructions for well-developed construction, for example, for fishing and other activities. The most important site, as I told, is Great Serteya Paleo Lake, upstream in the Serteya Valley, where there was excavated this pile dwelling that are very well preserved constructions somewhat distant from the lake shore at the lake littoral, that we have not only the wooden construction of this let's say buildings, but also remains of the floor, remains of textile strings, wooden traps, very delicate elements like baskets and so on. These artifacts are so well preserved because they are under the groundwater level, and they were covered very fast by the glaciers, and that's why this archaeological site is so important. They are excavated using wetland methods, aquatic archaeology. However, I don't want to focus on the archaeological aspects of the investigations in the Serteya River Valley. I also mention that in the last 2 years there were excavated also complete skeletons excavated in situ in the shallow littoral zone of the Paleo Lake, that are skeletons of 2 young women and also bones of the third human specimen. They are currently analyzed according to the paleogenetics, and they are also obtained very detailed datings of these bones. As I told, we aimed to give environmental background for this precious archaeological discoveries, and we collected 2 cores, one more distant from the Paleo Lake shore, in the more central part of the Paleo Lake. There were close to the pile dwellings. This is core ST2A, long sequence, the 8 meters length core collected by the Instorf corer, that covers all the Paleo Lake history from the beginning in the late glacial up to the modern times. There are 12 datings, IMS datings of the sediments taken from the plant macrofossils. Of each, 9 were used for the age-depth model. Second core was collected from the wall of the trench, just in the place where skeletons were recovered. And this is shorter core, about 1 meter length. There were used 6 AMS dates for age-depth model of this sequence. This study that I present here is a multi-proxy study from the ST2A core, that is the main subject of this presentation. We analyzed chironomids, cladocerans, plant macrofossils, fish remains, mollusks, and diatoms. And all these proxy were gathered together, were included into the large data set, and the zonation, the zonation of the sequence of this all proxy was analyzed using self-organizing maps neural network. This is quite a robust technique that maybe used for the paleolimnological data that in fact are not based on the modern proxy, modern communities of the, for example, aquatic biota, but on the remnants of the past communities, so they are incomplete. That's why the artificial neural networks work here much more precisely than, for example, classical statistical techniques like optimal partitioning. The self-organizing maps distinguish four main stages of the lake development that can be divided onto 7 sub-zones. Application of the self-organizing maps together with interval statistics allow for finding main paleoindicators that significantly indicate conditions in each of the zone of the clusters, and here there are presented only the most significant taxa with high P level. However, there are much more paleoindicators that reveal lower significance. I would like to present how these paleoindicators appear and work in the paleoecological sequence using Kiernomid proxy. And for example, for the V zone that covers late glacial and early Greenlandian, there are only 2 paleoindicators with the lower significance that are cold adapted oligotrophic taxa for the ecological stage of the lake ecosystem development. X1 that falls on early Greenlandian and early North Grippian. There are no any Kiernomids as paleoindicators, but other groups like cladocerans play the most important role in distinguishing this zone by the self-organizing maps. And the zone X2 that falls for the middle North Grippian is indicated only by 1 Kiernomid taxa. This is Kiernomus plumosus, eurytopic and warm adapted eutrophic taxa. However, for example, for the zone Y1, there is a number of Kiernomids that are the main paleoindicators of the stage, and these are mostly taxa associated with organic sediments, typical for eutrophic conditions and high summer temperatures. Interestingly, for the zone Y2, there is only 1 weak paleoindicator, and again, zone Z1 is represented by a large number of paleoindicators. Kiernomids play here a dominant role as paleoindicators, and that are mostly eutrophic phytophile taxa. Again, zone Z2, top zone, is distinguished by the other paleoindicators than Kiernomids. As I told, there are many other proxy. I'm not familiar with them, and can't give you detailed interpretation, for example, of the cloud-serum sequence, I can only say that this group reveal very high abundances for the early to mid Holocene section of the core. Diatoms are present only in the upper section of the Great Serteya sequence, and they reveal highest highest communities diversity for the zone Z1 that falls on the early Meghalayan. I'm sorry for the quality of the plant macrofossil stratigraphic diagram. I'm not familiar with this proxy and can't make well visible a proper stratigraphic diagram for this group. However, I want to only remark for you the zone Y2. This zone falls on the pile dwelling, on the period of the pile dwelling location at the lake littoral, and it is defined by among others 3 paleoindicators of the human settlement. For example, wooden remains, fish bones, and moss. Moss and wood was used for the pile dwelling constructions, and in fact these are remains from the floors and from the constructions of the building, and the fish bones are accumulated here in the large amounts because after the consumption of fish collected in the lake in the far distance from the pale dwellings and collected in the nearby Dvina river. Also in the next zone where there was no pile dwellings were abandoned, but there was still population living at the human population living at the lake shore. One of the leading paleoindicators is charcoal. Mollusks are represented only by the few subfossils that are aggregated only in the short, let's say 40 centimeter section of the core. It is not surprising for you that you well know the fact that Smolens upland is located in the continental temperate climate zone, and this fact is very important for the interpretation of paleotemperature reconstructions. We have 4 paleotemperature reconstructions from chironomids using Swiss, Norwegian, Polish training set, this one, with the weighted averaging partial squares technique, the classical technique, statistical technique used for paleotemperature reconstructions from chironomids, applied by us for the first time artificial neural network, also with the Swiss, Norwegian, Polish training set. The reconstruction made from the Russian training set, and another one from the East European training set that gather, as I taught in the last presentation, 200 sites from Poland and Finland. And these 4 reconstructions, as you can see, reveal very similar trends and also values. They well fit to the detriment correspondence analysis results. This analysis indicate main changes in the communities composition and taxonomical composition and domination pattern, so the share of each taxa. And the first DCA axis trends well fit to the reconstructions. Yes, it is reversed here, but you can see that trends are very similar. This proves that these reconstructions well fit to the communities, and the DCA here support results and prove reliability of the reconstructions. Two of the reconstructions based on the Swiss-Norwegian-Polish training set with the weighted averaging partiary squares technique and from the Russian training set reveal good modern analogs. Modern analogs indicate the fit of the paleo communities from each sample to the modern communities in the training sets. So if they are good, if there are close modern analogs, it indicates that we have nearly the same communities in the training set, that is the model, and the communities in our sequence. Good modern analogs are in the Swiss-Norwegian-Polish training set and in Russian training set. Finnish-Polish training set reveal here weaker modern analogs. However, the trends are similar. I like the reconstruction with the Swiss-Polish training set because it well performed the main trend of the temperature changes in the Holocene. Colder conditions in the Greenlandian stage, higher temperatures, climate optimum during the early North Grippian about 8,000 years before present, and then subsequent drop of the temperature, decrease of the temperature, with some significant decrease in the Meghalayan. And after 4.2 kilo event, this trend well fits to the last publication of Kaufman and co-authors that summarized big data set of the global paleoclimatic reconstructions. This trend here is in fact global trend. Also, the Russian temperature reconstruction, I need to mention that it is, of course, mean July air temperature. So it's not mean annual temperature, but from Q-nomics we reconstruct summer air temperatures. And here, interestingly, Russian reconstruction reveal quite a high variability of the temperature during North Grippian and early Meghalayan. Also, the passing to the climatic conditions in the Meghalayan is more smooth than in the other reconstructions. We also made a temperature reconstruction, marked here by blue, from the cladocerans. However, this reconstruction revealed poor modern analogs. What is not surprising, but it's a common pattern with the quantitative reconstruction using cladocerans. But the trend of these temperature reconstructions doesn't fit to the DCA trends that remark communities changes among cladocerans. So I would say that we need to create these results cautious. The DCA trends, the communities trends, much better fit to the quantitative water level reconstruction using cladocerans. Also, modern analogs are poor, but the trends in communities are more correlated with this reconstruction. And we can see here well that the Great Serteya Paleo Lake revealed higher depths, the higher water level during the late glacial. Later on in the Holocene, this was much shallower lake. And in fact, after 4.2 kilo event, the hydrological conditions start to be very unstable and the water level strongly varies. This might be a reason why the pile dwelling was abandoned soon after the 4.2 kilo event. It was surprising for me that the DCA analysis indicates that plant communities revealed by the plant macrofossils reveal very similar trend to the DCA, to the communities of the chironomids and to the chironomid inferred summer temperatures. This indicates that also plant communities in the lake were linked to the summer air temperatures. Also, diatoms, however they were available, they were present only in the top sequence. Diatoms reveal very similar trend at the DCA axis 1 as plant macrofossils and chironomids. That indicates that also for diatoms, the water temperature, maybe during the summer season, maybe also other seasons, was the most important factor for their development in the lake. However, second DCA axis presenting secondary minor factor influencing the communities is consistent with the diatom inferred trophic state of the lake, so the total phosphorus. As we can see, the lake trophic state decreased soon before the Paleolake drainage by the Serteya river valley. We made also paleotemperature reconstruction from the second core M25, so this one that comes from the more shallow littoral at the site exactly where the skeletons were found, the women's skeletons. And this core fell on the middle Holocene sequence from about 5.9 kilo event to the 4.2 kilo event, a little bit later and a little bit before. The paleotemperature reconstructions using chironomids also well fit to the DCA, so the climate was also the leading factor for the shallow littoral communities. And this mostly concern Finnish training set reconstruction and Polish, Swiss, Norwegian training set reconstruction. However, the Finnish training set reconstruction reveal here very good modern analogs, whereas Polish, Swiss training set, Swiss, Norwegian training set reconstruction, and the Russian training set reconstruction reveal weaker modern analogs. Nevertheless, these reconstructions are consistent and give very similar summer values. They all reveal weak decrease of the temperature during the 5.9 kilo event and also 4.2 bond kilo event. Yes, the weak temperature reconstruction, summer temperature reconstruction, summer temperature decrease. Yes, summer temperature decrease. And however, here much more important is are the reconstructions inferred from the pollen. we inferred the temperature of the coldest month and the annual precipitation from the pollen communities. And they remark very clear drop of the annual precipitation and serve winters for the bond events, and interestingly also reveal intermediate oscillation about 5,000 years before present. That is also remarked by the increase of the summer temperature inferred from the chironomids. So we can conclude that bond oscillation during the Middle Holocene were remarked mostly by the increase of the climate continentality at Smolensk upland, and the summer temperatures were weaker. Finally, maybe more laterally from this main paleoclimatic aspect of our research, I would like to pay your attention on some paleo indicators associated with the recovered skeletons. These skeletons of the young women were recovered in situ, so probably these bodies were deposited in this locality, and just in the sample where the skeletons were recovered, we have very high, exceptionally high accumulation of the charcoal. That may be some indicator of the I don't know, maybe some activity according to the funeral of the something like that. But also very high accumulation, very high concentration, exceptionally high concentration of the chironomid head capsules. And this was for us unexpected finding. And finally, we searched the forensic literature, the forensic sources, and it appears that chironomids are one of the first colonizers of the inundated carapaces in the water. They colonize bodies few days after inundation, after death, and mostly aggregate in the long hairs of the bodies, just because chironomids feed on the keratin of the hairs, but also this they remain for them microhabitats that they usually dwell, the filamentous algae. And of course, when the body is strongly decomposed, chironomids mine and feed on all of the decomposing carapaces. That's why this may be explanation of the high abundance of chironomids in this certain sample where skeletons were discovered, and is also the main proof that the bodies, the carapaces, were deposited originally in the lake littoral, and they were not transported from the land. Here are the main conclusions. And as I told, self-organizing maps distinguish 7 main ecological stages of the ecosystem, of the lake ecosystem development. And the mean July air temperature was a leading factor influencing not only chironomids, but also the other proxies, the other groups of aquatic biota. Whereas lake depth was the primary factor influencing cladoceranes, and the trophic state was the secondary factor influencing diatoms. The bond events 5.9 and 4.2 were marked in the region by the increase of the climate continentality and decrease of the summer temperature. And we have also third, this intermediate episode. Of course, these oscillations might be important for the local Neolithic communities, especially 4.2 kilo event, where there was advanced culture, advanced communities living on the lake shore and constructing pile dwellings. Thank you for your attention.